Hi everyone, and welcome to the flipped instructional recording for the lab 3.12. Today we're going to go through that chemical reaction lab. As we get started, be sure to take some notes in your science notebook. There are some things that you will want to write down and reference to help you as you work through the assignment. And don't forget that you do need to update your slide with this information as well, the guiding questions and things like that. So as we go into the lab, let's go ahead and get into the lesson introduction. So in this lesson, we're going to conduct an investigation to determine the identities of the products in a chemical reaction. So you can kind of see from there, we're going to do an experiment that the goal is to determine the identity of what is produced in a chemical reaction. So here's your keywords. Make sure you know the difference between the reactant and the product. And then there is the option in this experiment to actually do part of it at your own home. Like there are things that are easily accessible at home, baking soda, vinegar. So you can do this same test. The effervescent tablets are something like Alka-Seltzer. It's not like a Tums. So it has to be something that when you put it into water, it bubbles up. So remember, we have 3 guiding questions that we need to answer as we go through. So let me just copy that and I'll put it over to the side for as we work through the lesson. And so the first thing we're looking at is what happens to the properties of substances after a chemical reaction takes place. So that's the first thing we're looking for. All right, so reactants have different properties than products. So remember, the reactants are what you start with and the products are what you finish with. So after a chemical reaction takes place, the properties of products are different than the properties of the reactants. So there's your answer to your first guiding question. An example would be the outside of a marshmallow taste, looks, and feels different before and after it's roasted in the fire. So what you start with is different than what you end with. And if you remember back to the Unit 2 lab, we talked a little bit about indirect observations, and we used physical properties in that lab. We looked at the density of the unknown metal to figure out the metal. In this lab, we're going to look at the indirect observations related to chemical properties of a substance to identify something. So remember, we're trying to figure out what is produced in our chemical reaction. And so this is just a reminder that chemical properties can be observed by changing the substance's identity in a chemical reaction. Macroscopic patterns in the way substances react are related to the atomic level structure. Meaning, so that's a big sentence there. What does it mean? It means if we undergo a chemical change and we create a new substance, if you remember back to counting protons, neutrons, electrons, if we change an element and it undergoes a reaction to become something new, that means the atomic structure has changed. That means if we're dealing with carbon and it changes and the end result is not carbon, that means there's not 6 protons anymore in your product. So we're not able to see that, right? We can't see, that's why it's called macroscopic patterns. But we are able to do things that could show us what is produced. And so one example of that is flammability, and that's the ability for something to burn. We know that's a chemical property. So when a match burns, atoms in the match bond with oxygen in the air and form a flame, right? So you have to have oxygen. That's why some people will say, blow on a fire, you're putting more air into it to get your fire started if you were camping or lighting like your fireplace or something. So the more oxygen it has, it's going to bond with those oxygen atoms and the flame gets bigger, right? So we're going to be looking at the indirect observation of flammability here to compare kind of what happens in different situations and see what we're producing at the end of the chemical reaction. So in the experiment, you will test the chemical properties of the products of two chemical reactions, and you're going to compare your observations with those in several videos to identify the products. So we're going to be shown a series of videos that give us something to base our comparison on coming up. So as we get there, remember, if you actually decide that you're able to do this experiment in your home, you'll need to remember that don't eat or drink anything while you're doing the lab, dispose of your materials. I mean, again, you're using vinegar, baking soda, water, but you're also using an open flame, so you need to be careful with that. And so again, the lab report document is there for you. And so it says, this is the question you're seeking to answer in your investigation. And if you remember on your lab report, that's always question number 1. So we are looking to what is the identity of the gas produced in a chemical reaction. So we're going to be doing something and a gas will be produced. Remember, bubbles forming in something is a chemical reaction. So when we see the gas produced, we're trying to figure out the identity of that gas. And then as you work through the investigation, you should gather evidence to support your claim that answers your question. All right, so there are a series of videos that we have to watch and copy down, record data. What are we observing? So if we take a look, the splint test is they're holding a match over a test tube, and we know that there's oxygen gas present, and so you're able to see what happens when the match reacts with the oxygen gas. So here is the first video. All right, so as you were able to see, and as we just talked about with oxygen, if you're blowing on a match or adding oxygen to it, it kind of it wouldn't reignite a match, but like it could fuel a fire already lit. In this situation, you saw with the O2 in the test tube. So we know that O2 is pure and that the air that we're breathing in has other things in it. So if you've ever seen someone with an oxygen tank, there are warnings all around them that say, you know, do not get near an open flame. So we know that it is highly reactive. And if you look at this picture, you're able to see that the match reignited when it was exposed to the O2, the oxygen gas. Okay, so again, that's different from the air we're breathing in. So I would write down that oxygen reignited the match. That's what we saw. Okay, the next one, hydrogen, is a little bit misleading. So let's see what happens here. So again, hydrogen gas, okay, it is highly reactive as well. It's in the periodic table group 1. Those are highly reactive. And so let's kind of take a look and see what happens here. All right, so we're able to see that as soon as it comes near the hydrogen, the flame is extinguished. Okay, so I'm making a note of that so that you would make a note of that too to put in your data coming up. So the hydrogen, the flame was extinguished, it made a sound. You notice it kind of had that weird sound, right? And so we'll kind of come back to this one. I think the sound is kind of a factor in there as well. So that's something to note too. All right, now let's look at carbon dioxide. Carbon dioxide is something like when we breathe out carbon dioxide, CO2. So let's take a look. Obviously you can't see it, and it is a little confusing to look, how do you have a beaker full of CO2? So that's a little bit confusing, but imagine, yes, there is CO2 gas in there, because you will see what happens once the match goes in. All right, so again, if you missed it, you're looking, the match goes out. All right, and I don't know that you could have heard, I can't tell ever if the recording picks up the sound, but it's like a little chirp here. If you are not able to hear that in the video, it's a little chirp when that flame went out. And then here we just saw it got kind of dipped in to the beaker and it went out as well. So we need to know that so that we can remember what these gases are. Remember, carbon dioxide is CO2. We know that the flame went out. That's something we need to know. Hydrogen gas is H2, oxygen gas is O2. So you need to know all those things kind of going into the next part. So this is the flaming splint test with the virtual lab simulation. So we're going to use these results and look through. Again, you do have the ability to test it on your own, but we're going to follow the steps here. So using the simulation to conduct a flaming splint test, similar to what we saw above, we want to identify the gas produced. Okay, so what do we think is produced based on what we saw earlier? I will say that this lab, the hydrogen gas normally would have, if the flame extinguished, that one, there's just something not right with that. It really shouldn't extinguish because it makes the results of the splint test misleading. So I'll kind of go into a little more detail on that later. So we know what we saw in the video was that O2, the match reignited. So the flame, it was flammable. With H2, hydrogen, the flame went out. And then with CO2, the flame went out. So that's kind of our comparison here. So the first thing it says to do is to select the vinegar and add it to the Erlenmeyer flask. So you do that. And then you select and drag the baking soda into the liquid. All right. And now we need to kind of figure out what's happening here. We see bubbles. Bubbles, like if you drink a soda and you know there's bubbles in there, it's carbon dioxide gas, right? Usually that's what we're thinking, carbon dioxide gas released. We're guessing, maybe that's our hypothesis here, is that we're seeing bubbles and we're guessing on the gas that's released. Is it oxygen? Is it hydrogen? So we're going to kind of test that. So it says pick up the match, place it over the opening of the flask, and record your observations. So if we put it over, it went out. Okay, so if you're creating some kind of data table or just a chart, it doesn't really have to be a table, just some kind of chart that's got vinegar plus baking soda equals 0 flame, right? The flame went out. Okay, we know that vinegar is acidic. We know that baking soda is basic. So those are just things that can help us. So now we're going to record all that down. We're going to reset it. And we're going to repeat the experiment with the other combinations of the liquid and the solid. Okay, so what about water? If we fill it with water and we add the baking soda, do you see any bubbles being released? Maybe, we don't know. What happens if we hold this over? The flame is still lit. Okay, so nothing really happens here. So that could be a trial. Water plus baking soda equals flame. Okay, so we reset it. Now let's try lemon juice and baking soda. What happens? We see bubbles. Bubbles seem to move a little faster. All right, so we see the same kind of thing. So we have lemon juice plus baking soda equals no flame. Okay, we reset it. Let's try vinegar, effervescent tablet. Bubbles, no flame. Okay, so vinegar plus the effervescent equals no flame. All right, reset it. Let's go to lemon juice, effervescent. And what happens? No flame. So is there something with the vinegar and lemon juice being acidic, baking soda being a base, effervescent? They both cause bubbles, so there's a gas release there, and it went out, right? The flame went out. So if we compare that back to our chart of what we saw at the beginning, we know that it's not going to be hydrogen gas that's released. I mean oxygen gas, right? Because oxygen reignited the flame. So it's not oxygen that's being released here. Okay, so let's go on. This is the procedure if you actually chose to do the experiment at home. This is what you would do. Okay, so from here, it tells you, great, you've done the activity, and you need to kind of go through now and take a look at, let's do this report. We want to pull this over and just look through these questions. But we also, if you want to look at the guiding questions and make sure you have those answered in your notes, you've got what happens to the properties we answered. How can chemical properties be used to identify a pure substance? Okay, so we were able to see, you know, if it's flammable, maybe it was toxic based on that screen that we saw at the beginning of the lesson. There were 4 different things there that you could use to identify. And then what is the purpose of this experiment? So if you remember, it is to identify what's produced in this chemical reaction, to identify the gas. All right, so we're going to close out of that one and we'll look at these questions. So if you want to figure out the purpose of the experiment, we just stated it. It's back in the lesson. So next, how can you identify the gas produced in a chemical reaction without observing the atoms and molecules directly? So if you think back to the slide that we looked at about indirect observations and identifying something with a chemical property, maybe you could explain there how that might work to use a chemical property to identify and what that's called. And then if we were writing a hypothesis based on what we were trying to do here, we know we've been trying to follow that. If I do this in the experiment, then I should be able to do this. So if, you know, I get a baseline and I'm able to determine some indirect properties that could help me identify a substance, then I will be able to identify the gas produced in the chemical reaction. Something like that. You're talking about, you know, what you're testing versus what you think the outcome will be. Again, you can always fill out your tools and materials. Your procedure is just step-by-step instructions of what we did to go through the lab. Remember that we went through and recorded everything we saw in the splint test. Then we recorded everything we saw and what happened for the different combinations of things that we put in. So you could just write that out here, or you could put it into a table if you wanted to, but you can write it out, no problem. And then the conclusions, it's asking, what are you able to determine about the identities of the gases produced in those reactions? And so it says, write an evidence-based claim. That means you're writing about, based on what you saw, you're able to say this. So if we go and think about, again, take hydrogen kind of out of the equation. I think that was done incorrectly in the lab. What we should have been able to see is that we know carbon dioxide gas is produced when things bubble like that. And so carbon dioxide was produced in those chemical reactions because the lit match went out when it's placed in the container, right? So that's how we were able to tell. Now, hydrogen, again, in that video, it's there and it's a factor. I think that's an error in the lesson. So scratch hydrogen being in there altogether. And then, so your conclusion, you're just writing that and then making sure you have evidence there. And then when you get to question 3, it shows you some different chemical reactions that are happening. It shows this C2H4, this is vinegar. The next one is baking soda. So you're seeing that combination together produces something new, right? This looks different than what's over on the reactant side, plus water, plus carbon dioxide. Okay, so that's one choice. The other is it's showing, again, vinegar and baking soda producing new substances. You've got water and oxygen. Okay, this shows the same thing, but produces water and hydrogen gas. So again, take C out of the equation. Take the hydrogen gas as extinguishing a flame. Just take that out of the equation. And then D, you have, again, similar to A, if we look at it, the vinegar and baking soda yields, you've got a product of water and CO2. Okay, so the difference in A and B, if we take a close look at those, look here, okay, and then look at this one and see if there is a difference. Okay, so hopefully between those, you can choose the correct one and identify why the one you do not choose is incorrect. Okay, so then you can justify why the one you chose is correct. So that is how you go through and do that lab report.